In the last video, we learned about functions and what functions are, so we're just going to continue with that in this video. So let's talk about domain and range. Domain, as a reminder, is all of the x values of a function, and range is all of your y values. Your x-intercept is where the function hits the x-axis, and the y-intercept is where the coordinate hits the y-axis. Okay, so let's go through an example. So looking at this function, in the previous video we learned whether this would be a function or not, and we can do that by the vertical line test. This does pass the vertical line test, so it is a function. One-to-one means it would pass a vertical line test and a horizontal line test. And then we can see in this case, a horizontal line test, it passes through more than once, so it's not one-to-one. Okay. For domain, what we're going to do is, it's our x value, so we're going to think left to right. So if you put your finger on the function and follow the function until you get to the leftmost point, you would end up right here. And if you follow it to the rightmost point, you would end up right here. Wherever you see an arrow is going to represent either negative or positive infinity. So when it's on the left, it would be negative infinity, and on the right, it would be positive infinity. Okay, so domain is left to right. Range is similar, but it's going to be from bottom to the top. So on the bottommost part of the function would be here and here. So that would be a y value of 0. And we put a square bracket, meaning it includes 0, so it actually touches that point. And then the topmost point of the function are these arrows again, and arrows mean infinity. Okay? If you had an arrow at the bottom of your function, it would be negative infinity. Top of your function is positive infinity. X-intercepts are just where it hits the x-axis. So that happens at -3 right here and at +1. And we write those as coordinates. And then the y-intercept is where it hits the y-axis, which would be at 0, 3. Okay, so go ahead and try number 2 on your own, and you can check the notes on Schoology to see if you got them right. Moving on, we also have function operations, which we've done previously in your other classes. So let's go through this real quick. If you have f plus g of x, we are just taking our f function plus our g function and putting those two together. So this would be x squared plus 3x plus 1. And then we just combine like terms to get our final answer there. Okay, this should be a review. F minus g, same thing. We're going to take our f function and then subtract g function. I'm putting it all in parentheses because we need to distribute that negative. So this would be negative x squared plus 3x plus 1 minus 2x squared plus 5. And then combine like terms. Okay. When it's a dot, that means multiplication. So negative x squared plus 3x plus 1 times 2x squared minus 5. All right, and then lastly, f over g, we just put f function in the numerator, and then g in the denominator, and then we always want to set the denominator to not equal 0, and include that in our answer. So x cannot equal plus or minus the square root of 5/2. And that means if we had plugged this into the denominator, we would divide by 0, which is impossible. So you always include that extra little piece. Okay. All right. We already did examples like this in the previous video, so you can go ahead and skip those. All right. So moving on to composite functions. This is where we have f of g of x, or it's written like fog, f of g of x. And this is where we're plugging one function into another. Okay, so we're going to find a composite function now. So this one's saying find f of g of x. So I'm finding f of, and I'm plugging in g into f. So I have that f of x equals x minus 6. And this is telling me wherever I see an x, I'm going to replace it with my g of x equation right here. So I'm going to do f of x squared plus 6x minus 2. So I see an x, and I'm replacing it with x squared plus 6x minus 2. Okay? And then we just simplify. Squared plus 6x minus 8. And that's it. Okay? So try letter B. For C, we are going to work from the inside out. So I'm first going to find g of -1. So g of -1 so 1 minus 6 minus 2 is -7. And since I found g of -1, I can rewrite this as f of g of -1 is -7. And then I can just plug in -7 to my equation. And then that's your final answer. Okay, we're going to do that same idea with the table and the graph. So for the table, we're first going to find f of 4. So this is where f is. So when x equals 4, y equals 1. So f of 4 equals 1. So I'm replacing this with 1. And now we're going to find g of 1, which is right here, and that equals 3. Okay, we're going to do the same thing on a graph. So first we're going to find g of 1. So here's our g graph. So I'm looking at where 1 is, and my answer would be 3. So g of 1 equals 3, so I plug that in. And then f of 3 equals 6. So that's your final answer. All right, last little part. So now we're going to talk about inverses. So an inverse is where you take a point A, B, and you switch it to be point B, A. So algebraically, we are switching x and y. Graphically, it reflects over y equals x. And for notation, this one is f to the -1 of x. So if you see this notation, that just means inverse. Okay. So to find the inverse, step 1, we're going to switch x and y. So x equals 3y plus 2. I literally just flip-flop the x and the y. And then you're going to isolate y, which means get y by itself. So we're going to subtract 2, and then divide by 3. And then we write this as f inverse equals x minus 2 over 3. Okay, go ahead and try letter B and see if you can figure that one out. All right, last one, number 8. The way you inverse a function is just by picking out some key points. So I'm going to pick -3, -3, negative, or 0, -2, 3, -1, and then 6, 0. So if I write out these points, then we just talked about an inverse just means you flip x and y. So if I flip -3, -3, it's still -3, -3. If I flip 0, -2, that would be -2, 0. We'd have -1, 3. And then we'd have 0, 6. And then that's your inverse right there. Okay, and you should make this a straight line with a ruler, but I can't do that on this iPad. So that's what it looks like. Okay, so try the other graphs, and that's it.